Okay, welcome to episode 2 of the Stealth Racing podcast. And today we're joined with Yash Patel. He's one of our partners from Austin Mayor Engineering Society from Cambridge Downing College. And today we'll be talking about the design and engineering portfolio. Last time we talked about the car and what makes a good car and what makes a good design. Today we'll be talking about how to actually document your design process and how to get the most out of that scorecard.
Cool, yeah, thank you for having me. Yeah, let's get into it.
Okay, so first question.
Yeah.
From a Cambridge engineering perspective,
hmm
what would you be looking for from one of these portfolios if you were judging or if you were reviewing them like you did with us?
Yeah. So there's there's quite a few criteria you have to hit. If you're looking in terms of portfolio, you want something which is going to communicate your design to the judger as efficiently as possible. You want them not to have to struggle to read your design and your portfolio. You don't want them to have to interpret what you've written. It should all be very clear, easy to read, and then if you want to have a bit of an impact, leave a lasting impression, it should have a little flair, a little bit of style. Now you guys did send your portfolio, and you were using your sort of logo colors, which was good. That that sort of branding will help you stand out a bit. But then I noticed some of the things you felt a little short on, which you've since improved, were some of the layouts. There's just a lot, like lots of blocks of text. Nobody really wants to read lines of text. So yeah, visual communication, a bit of style, a bit of flair. It's pretty important.
Would you say numbers are a lot more important than words in
Mm.
conveying your information because the judges are going to be engineers, I'm presuming?
Yes, this is an interesting thing. So when you're in school, you don't deal with numbers much at all in terms of an engineering context. And then when you get to uni, everyone realizes they hate words and that they just want to stick to numbers. And so when you're expected to do lab reports and whatever, um, people just love throwing equations in, but they don't have the sort of writing skills to be able to communicate.
So would you say there's a right balance between words and numbers, and what would you say the balance is roughly?
Yeah, sorry, yeah. So sorry, I just interrupted my sister. Yeah, it's you should be writing down the equations and stuff which are informing your design. It's all about showing how your design is progressing and what's informing it. You know, let's say there's some sort of curve on the the blade or the aerofoil for the shape of your wing. What's determining how wide it is, how long it is, the equation of the curve which it follows. Um, that's all done by mathematical reasoning, and that's where numbers get involved. Now, there's a balance between just throwing in random numbers which mean nothing and real data which is being cleverly manipulated to show the reader the trends. So you don't want to just throw in a bunch of random decimal numbers without any clue as to what it actually means. You need to put it into a format, i.e., graphs, charts, if you're fancier and you have more resources, simulations, visual simulations, sort of anything visual which communicates to the reader that, okay, there's a clear link between performance and width of the aerofoil or whatever. So in terms of a balance, really it just depends on, is it scientifically clear enough why your design works?
Okay, so what I got from that was add as many numbers as you can, but don't just overpopulate it. Make sure you explain everything and make sure you actually understand what you're saying to
Yeah,
the judges.
yeah.
Because sometimes what happens is the judges, they look at all the numbers, but when they ask, because it's going to be a one-to-one little thing with the judges, when they
Mm,
ask you, oh, what do these numbers mean, or what does this table mean? What does that
mhm,
actually impact
mm,
your design?
mm.
So they get stuck and they're like, I don't know.
Yeah,
And I think one of the most important things is knowing everything on your portfolio. And the best way to do that is by documenting everything. that
Well,
you've
yeah,
done day one.
yeah. Well, the aim is so that they don't even have to ask you like, what does this mean? It should be just clear from what you've written.
Yeah. So just make sure you're clear in writing everything and make sure you have good visuals to back it up. Let's say you did some CFD testing, have
Mm,
the CFD table, but also a picture of the CFD, and also know what the CFD meant. Like, let's say you had a lift coefficient of minus 0.03 or something,
mm,
and you're told to analyze that.
mm.
Instead of letting them ask you, might as well add it in if you have the space.
Yeah.
And a lot of people, I think, they ignore real life testing. How important do you think real life testing is compared to just CFD? Because that's a whole
Yeah.
scorecard
Well,
criteria.
I suppose I can link this to one of our coursework. So we have to design from scratch and sketch and build um, a steel bridge essentially, and it has to withstand a certain load, and it has to then break at an ultimate load as well. So not only does it have to be strong enough, it has to be just about strong enough so that it breaks at exactly within 5% of the target load. And this is all based off of theoretical calculations. Now, it's all well and good having those theoretical calculations. Everyone in our class who pretty much did it correctly. Um, Majority of the time, like some calculations might have been wrong, but like most people will get their calculations correct. When it comes to actually building this thing, this is when you realize that build quality is gonna affect your final performance far more than the little 0.1% error in your calculation will. Um, I think ultimately, so our bridge was actually the best in the cohort. It was the only one to get above the working load, hit the ultimate load, and then break within 5% of it. And that was, I would say, down to build quality, actually sticking to our design, and that showed in the real life testing. And obviously, it's this thing of theory versus real life. Real life is what we're dealing with, so of course, test in real life. There'll be conditions you can't foresee, um, things you can't always predict, especially when you don't have the maths right now to back it up.
Okay, so I think that quite nicely links into the other criteria, which is use of CAM and CNC.
Mm,
So what they really want to see is, have you shown your knowledge of CAM by actually designing a car that's CAM friendly and
yeah.
not too many sharp edges? And I think that links really nicely into what you said about actually making your design viable in real life.
Mm,
So what we did was we made sure there wasn't that many sharp edges, partly from our research showing sharp edges weren't as good as rounded corners for uncontrolled vortices and stuff like that, but also for the cam toolpaths and all of the stuff our other sponsor Freeform had to do with the CNC cutting. So we just wanted to make sure that there was the least possible chance of any machined marks that can affect your build quality
mm.
at any stage. So I think that's basically what you were alluding to in that as well.
Yeah, design for manufacturers probably one of the most overlooked things that developing engineers don't really sort of take into account. um, yeah, it's really important because you have to be able to make what you're designing. If you're theoretically astounding new piece of technology is 10 years ahead of its manufacturing time, then what can you do? So yeah, it's
Yeah.
definitely very important.
And one of the most vague criteria that I thought, obviously, with my team when we were reading it was design process evaluation. The top
Mm,
band says excellent ongoing idea evaluations linked to improvement actions. Do
mm,
you think that deserves its own page at the end, or do you think it's more continuous flowed throughout the whole
mm.
page?
I would say continuous. Um, in DTA level and GCC, one of the key, so we would follow design processes, and one of the most common and effective processes is iterative design, which is essentially a cycle of research, design, build, test, evaluate, and then you tweak your design, you test it again, evaluate it again, check the results. Then again, if you need to make other changes, it's a cycle of, you know, test and evaluate, test and evaluate. You know, your final prototype is never really a final prototype. It can always improve, especially when you're just starting out. At the higher end, like Apple iPhones, they're pretty much at the peak of performance. Um, but right now, when you're starting from scratch on something like a complex project like this car, you know, there's a lot that can go wrong, a lot to be improved on. So definitely show it throughout the criteria, your PowerPoint or whatever.
Yeah, and that links nicely onto another point on the scorecard that actually says iterative testing
Mm,
and changing your design after your testing and testing it again.
yeah,
And that just shows like the scorecard is so interlinked if you just read a little into it and read between the
mm.
lines a little.
Yeah. Well, it's not
And
simple. Nothing like this. It's never a simple task of do this, do that, then you do this, then you do that. It's all very linked. Even like in my DT, there'd be like a sort of a set sort of route that people are meant to follow, but in actuality, if you're going to do it correctly, you sometimes have to jumble up the order, do some things first, do other things after. Yeah, it really depends.
yeah, you mentioned DC, A-level, and GCSE quite a bit,
Yeah.
and there's quite a few people doing the competition who actually take DT as well.
Mm.
So they might be wondering, oh, what's the difference between your normal DT and EA and your portfolio for this? Like, what would you say are the main differences from what you've seen so far?
You have a more um sort of refined brief. Your brief is a lot more specific. You know what context you're working in already. It's going to be a car. Essentially, you know what you're designing for. It's just a matter of getting it done and doing all the research now. And NEA is very broad. You essentially get to pick any problem in the world to solve. Whereas your problem's already set out for you. You want your car to go as fast as possible in this amount of time on this type of floor, etc. Your parameters are set out for you basically. DC also obviously much longer time scale, and that can affect basically how good your car is at the end. Obviously, if you have infinite time, you could make a masterpiece. So part of your challenge is going to be how can you balance as much research as possible with enough time to build, test, prototype. Because often in DT, you can make a couple, 3 to 5 prototypes, depends on the fidelity of it. But for you, you may get like 1 or 2 high fidelity prototypes before you have to test, and so you need to make as many improvements as you can. Test all the important stuff. You might not be able to test certain more what's the word? I guess more particular aspects of the car. Like is the profile of the wing gonna make much of a performance difference? Ultimately, it's not gonna matter if you haven't sorted out your dimensions correctly or the way it's assembled correctly. It's all a
Yeah.
balance game.
And I think the fact that we have limited scope as well compared to the DT and EA makes it so that we have to be much more technical and much more in-depth with our
Mm-hmm.
explanations, which is what they obviously expect at this level.
Yeah.
Yeah. So I think that's it from me. Do you have
Yeah.
anything else you'd like to say?
No, just good luck. Hope it goes well. Let me know of the outcome. Send me videos.
You get
Yeah.
everything, don't worry.
Yeah. Thank you. Thank you.
Huge thank you to Yash and Austin Mayer for supporting us and being on this podcast today. And
No, it's a privilege for
yeah,
us.
hopefully this was useful for all of you teams watching, and we'll see you next time for our Enterprise podcast, which will be coming out soon. Bye bye.
Bye bye. Bye everyone.